Yeah, so good evening, everyone. I, Swarali Pathak, welcome you all to 116th episode of CC Friday. Today we have an important topic, key principles of good question making. This session will help us understand how asking the right questions can promote deeper learning and make our classroom interactions more meaningful. Uh, we are fortunate to have two experienced presenters from EISET with us today, Ms. Aarti ma'am and Ms. Hetal ma'am. So just giving you brief introduction about them. Ms. Aarti Iyer is a senior academic consultant with over 8 years of experience in teaching, curriculum design, research, and project management. She is a passionate about using data and pedagogy together to bring positive change in classrooms. We welcome you, ma'am. Thank you so much for joining in. Next, we have Ms. Hetal Parmar ma'am with us today. She is an academic consultant with more than 10 years of experience in teaching, special education, and counseling. She has worked extensively in training teachers and supporting learners with diverse needs. We look forward to learning from their expertise. Let's warmly welcome Miss Aarti ma'am and Miss Hetal ma'am today for CC Friday. On behalf of DPS family, I welcome you. I welcome three of you. Thank you so much for joining in. Okay, now without wasting much time, just let's start the session. Over to you, ma'am.
Thank you, ma'am, for such a warm introduction. Thank you, everybody who have joined in. I understand you're not traveling, but I can see your camera on. Thank you for the dedication you're showing. I will just present my screen. Let me know if it's visible. Is my screen visible?
Yeah, Hetal.
Just give me a minute. My full screen is seen, or are you all able to see anything else as well?
No, it's just the slideshow. I think slideshow.
Okay, great. Yes. So today's topic, like ma'am said, we will be understanding the key principles of good assessment. So before we start, let me understand from you all, what do you think good assessment is, and which principles are you maybe already using, or what's the thought which goes behind designing an assessment? If any of you can share with me. Anybody, any teacher with your experience in designing so many assessment over the years, right?
For me, a good assessment. Okay, I'm Bharti from
Yes,
Delhi Public
Bharti.
School, Nashik.
Yeah.
For me, good assessment, if it is teacher centric, I don't think it will be good. But if it's student centric, now what do I
Hmm.
mean when we say student centric? As per the need of my children, what they
Hmm.
need, not
Hmm.
what I want them to achieve.
Hmm.
So
Hmm.
if I say student centric, that means I should be already having a pre-assessment,
Hmm.
and like I should be knowing. And also we
Hmm.
create differentiated assessments. So for me, differentiated is the best assessment I can share. Thank you.
Okay, catering. Thank you, Bharti ma'am, for sharing. I think catering to diverse learners and understanding that, what is the process in which students are registering the concept, and do they have core understanding of a certain thing, or is it just the peripheral facts around it? So we will actually deep dive into all of this in the coming hour. So first we'll discuss what are the objectives of assessment, why ask good questions and defining what good questions are, and that'll be followed by key principles of good assessment. So this session I'll be doing, and along with me I have Miss Atia here. We'll be doing this entire session with you all, and any questions if you may have. So now coming to objectives of good assessment, right? What we see on the screen is a circle which has three bits, which it says assess, diagnose, and remediate. So the whole objective of it, like there are multiple reasons, right? But the top reason of why are we like, doing assessment is firstly to understand that how well children have like, comprehended the concept. And if yes, it's still what level. If no, then what is the gap, right? And then once we understand the gap, we will work around the remediation and different approaches to cater to that particular question. And again, like how we do recapitulation after every lesson plan, we reassess if they understand the entire concept in totality, and if they are able to, of course, attain the desired proficiency level. At any point in time, if you have any doubt, please feel free to unmute, raise your hand, and speak. So, defining the objective, right? Assessment is for learning and no longer assessment of learning. So, after we are done assessment with the children, right? After we are done assessing the children, we know what our data is saying, what is the learning gap, and again, we take feedback from that and make remedials around it. Like Bharti ma'am said, right? It needs to be student centric. So, the role of questions is to meet the three objectives, which is assess, diagnose, and eventually remediate. So now, speaking so largely of assessment, right? Why ask good questions? And before that, let's define what good questions are. So, like Carl Jung says, that the right question is already half the solution to a problem. So now, when I say defining a good question, what will a good question do, right? It is going to stimulate critical thinking and what we call as HOTS question, right? It stimulates critical thinking. It exposes children to different orientation of questions, wherein though we are testing the similar concept, right? But how are we even questioning that largely depends on how deeply the child has understood the concept. Secondly, through that, we also understand what are common misconceptions, and depending on the data, we understand what misconceptions are, and then we plan the remediation. And when we do that, that is actually like having a targeted intervention and remediation, which eventually is improving our teaching, and the way also the students learn, the way we are teaching is also evolving, right? And again, very important bit is we should be able to tell that our children are able to distinguish what is mechanical learning from learning with understanding. Say, for example, we do have questions which may come from a recall base, but also it's essential to have questions which is testing the application of it. And on that note, we will actually deep dive into what are the key principles of a good assessment. Any questions so far? Anything you all want to know? If everything is good, maybe you can give a thumbs up.
ऐसी जगह पार्क कराओ जहां निकाल सकती हूँ मैं आसानी से। थैंक यू।
Yeah, okay. Thank you. So, now let's dive into key principles of a good assessment. On this note, I would also want to inform that, this is something which EI designed in collaboration with CBSE, wherein to understand, like, how varied children register concepts. So this was done in collaboration with the board. So let's understand principle number one, right? It says testing key concepts and core knowledge, and not just peripheral facts. Now, what do I mean by this? It's also followed by the example which you can look at on the screen. So not everything that can be asked should be asked. Rather, assessment should focus on the concepts. So for example, over here, can you all tell me what is the difference between two questions and what is that we are testing? The first one says, what are the properties of a solid substance? Versus, which of the following closed bottles definitely contain a solid substance? What do you think we are testing, and what are your reflections on the question? Anybody?
first one seems to be direct, other is indirect. It's helping
Oh,
children to think more, probing.
okay. Nisha, ma'am, you've raised your hand.
Namaste, ma'am. So, actually, I'm traveling, so my voice might not be clear. So, the thing is, ma'am, actually, in the first question, like as Bharti ma'am said, it's a straight question, direct question to the point. But in the second one, the child has to, recollect the properties of liquids as well and
Hmm.
solids as well, apply
Hmm.
the concept what he has learned, and then answer the question. Thank you.
Correct, correct. So the whole essence of learning is to understand if children know what is a solid substance, and meanwhile they are also looking at different examples. Now, if we look at four bottles, right? If it's like the option D, of course they would not know. We cannot tell. But now, when it comes to solid, whether it is C or B, that's where they need to, like, actually apply their mind, and that is how they are going to correlate and tell that, say if it's a liquid, so option C we see, right, that maybe it's a liquid, hence the water is fluid, or any liquid which is fluid. But when you look at option B, right, it is my voice audible? I can see some chat, the voice is breaking. Is everybody able to hear? Maybe you can just give a
No, ma'am,
thumbs up.
it's clear. It's clear.
Okay, great. So now option B, right? That will have a solid substance. Why? Because it did not change its form. So though, like, both questions are looking at the properties of solid substance, but the way it is tested is so different. The first one may come from a memory of recall of understanding what a solid substance is, versus second is the application of it, right? When you apply the concept, register that what a solid is in different orientations, right, is what we are testing. So that covers up the principle one, which is we test key concepts and core knowledge, and not just facts around it. Like, we understand, of course, facts around it are important, but as important it is to apply that knowledge and then make an assessment around it.
Yeah, Hetal, I'd just like to pause for a second. You showed
Yes.
a very interesting science example. So I would invite math and English teachers to just give one example according to you. What do you think would be a core knowledge or a core concept in
Hmm.
your subject? And what would be a peripheral fact? If you could just think from any chapter that you're teaching and give me one example from math and English.
Anybody, any teacher for math, English, any grade level, anything you can think of, wherein you curated maybe a personal response question in English, or something in a different way to understand multiplication, for example, wherein maybe we are testing place value, anything of that sort. I'm just giving out examples, anything you can think of.
Yeah, Prabha ma'am mentioned fraction.
Fractions.
So, what would two examples be in fractions where one is testing a very, okay, maybe concepts of half and full. So, could you think of two questions which would demonstrate this difference? What's a standard way of testing where the students know that an object has been divided into half versus what would a better way of testing that be? Even if you don't have answers right now, one caveat is because we have limited time and we have teachers from all three subjects joining in this session, we may not be able to give example for each and every. Otherwise, like the number of slides and the content will really increase in the scope of this 1 hour, and we do want to end on time. So the principle is broad. You can apply this with social studies. You can apply this with science, English, any subject. Just try and think in your area, what would a core concept be? What would a peripheral fact be? And you'll have to start seeing this whenever you teach. So suppose you're like tomorrow you're starting a new chapter, you may have to make those decisions like, what do you think? Okay, I have to cover my chapter and complete my chapter, and it has these many pages, and this is the content which is kept inside this textbook. What do I really want my students to know, and what is something which is nice to know, like which is like good if they know, but it's okay. any question that be framed with what is knowledge and why it would be discursive. Okay, we're talking in theory, just try to think of very specific examples, like the way we've done this is homework for you all, and we'll keep giving you these kind of prompts whenever we discuss a principle, so that we're not restricted to one example, one subject's example. Yeah, thank you, Ethel. Please go ahead.
Yes. So extending to what Aarti said, right? It should not be just like stuck to only the facts or peripheral areas, right? Here, what is it saying? The things which are good to know, nice to know, the things which are important to know, which is testing foundational concepts and skills, and then enduring understanding is what we actually call big ideas, which is worth understanding. So here I have an example, right? The first one which says, what were the names of Mussolini's parents? But the second question is saying, read the two sources describing the impact of Mussolini's action on World War II. How far do these two sources agree? Explain your answer using the details. So what we see here is both the question, like the second one is testing, and we need to also check, like, if children understand comparing different viewpoints, how are they interpreting historical evidence, are they able to draw reasoned conclusion. So everything around it is what is getting leveraged, and hence understanding like the big idea is how you are framing the question, and exactly how is children are going to think on that, right? So the more we expose them to questions which are critical in nature, they understand that, okay, this is how we are also supposed to learn, and they know that the questions are, say, not going to be simple, they are going to be the hot question. So we also, like, to support this thing, we also have something which we call as an essential concept booklet, wherein we actually designed this during COVID. Again, the whole idea, the intention around it was to test and teach core concepts, right? So it shows which are the essential concepts in a particular topic. We also have an example which can be skipped, and we also have an example of a question which is worth testing. So again, this was done in collaboration with CBSE. Now, moving on to the principle 2, right? We actually here, it says that we use questions that are unfamiliar, either in the way they are framed or in their context. So let's actually just spend 2 minutes reading what we can see on the slide and what is it asking. Maybe anybody can volunteer to read out loud. Anybody can unmute and read. So here the entire, has everybody read? Maybe you can give a thumbs up if you're done reading. I know it's a little text heavy, but it's a very, very interesting question. So please ensure you do read it. If you're done, maybe you can just give a thumbs up.
I think Gitanjali ma'am is trying to say something. I don't know. If you're not, I'm sorry to.
Okay. Read it. Maybe I get a few thumbs up, then I'll go ahead. Thank you, Ritu ma'am, Uday sir, Ratna ma'am. Okay. Great. So what is this testing, teachers? What are we testing? What's the concept which is getting tested here? Science teachers, anybody? Evaporation. Thank you, Sucheta ma'am. That is exactly what is being tested. Yes. Thank you, Nalini ma'am, Ratna ma'am. So here we are actually looking at the outer earthenware. What is it saying? That if it gets replaced with stainless steel pot, how would this affect the working of the setup, right? So it may look very unfamiliar to student. Why? Because maybe they've not seen a zero pot. But what students have to understand is, say, steel is not porous, so water cannot evaporate, and without evaporation, cooling cannot happen, right? So this is the exact reasoning what is getting tested here. So we use questions that are unfamiliar, either in the ways they are framed, because of course this is a way in which which is not so familiar with the children. And again, what we are testing is a very, very simple concept of evaporation. So another example extending to this is one is a question from board question paper, and the right one is from a sample question paper, wherein here we do notice that the questions come from everyday context, right? The first one talks of a goofball, and the second one is talking of an airplane. And again, it is testing the same core concept of math idea which we're actually teaching in class. But again, what it means is, are they able to apply these concepts into new situations? And when we ask such questions in class, in assessment, we are actually moving away from rote learning to ensuring that children learn how to think very flexibly and use this knowledge very meaningfully in the real world, right? So again, testing of the concept remains the same, but the orientation of it is different. Any thoughts, any questions so far? Any reflections?
So have you all also noticed the board sort of changing the type of questions since the past few years? Like the CBSE talks about now, I think there was a circular which was there was a newspaper article which was released where it was said that just this last week that the CBSE now wants to keep 80% of the questions competency based.
Yes.
So now, and this change has not come suddenly. It has been happening gradually, maybe with one or two questions and dheere dheere. And another thing is, one perception that teachers may have is that competency based questions, or these questions which are unfamiliar, need to be very lengthy. Now we have shown two questions which require a bit of reading and which do require a little bit of like there is a lot of context provided in the question itself before the child has to solve. But unfamiliar question need not be lengthy, right? They just need to be in a format that students are not exposed to. So this is again food for thought. Can you think of an example with your regular grammar? Students learn tenses, students learn basic arithmetic. What are some ways in which you could ask the same thing without increasing the length of the question, but in an unfamiliar context? Right. So if you notice, one feature of these unfamiliar questions is that the question is not spoon feeding what concept is being tested. Hetal, if you could go back to the previous Zeerpot wala question.
Yes.
So now, as you're all teachers, you could pinpoint ki, okay, the student does need to know the concept of both evaporation and also conduction. And but when a child sees this kind of a question for the first time, they have to even read the question and process the information given, and also figure out ki, what concept have I already learned to apply over here. So now this is something which makes if I give an example from grammar, right? A lot of times our typical textbook examples are like, convert this sentence from into the present tense, right? We tell students what to do. But in real life, when we are speaking, when we're writing, nobody tells us that it should be present tense, or it should be present continuous tense, or present perfect tense. We have to figure out how to talk, how to write based on the situation. So we have learned the concept of tenses, but how to apply, nobody in the real life is going to spoon feed us and tell us ki ye use karo, wo use karo. And similarly, when we are actually applying mathematical concepts to figure out what to fit inside a box, or what do I like, okay, I want to pack something, what should the dimensions be, how do I fit this thing inside? nobody is going to then tell you, okay, this is the formula for area, or this is the formula that I'm supposed to use. You have to figure that out on your own based on your prior knowledge. So unfamiliar questions need not be lengthy, but they need to be they should help students exercise that judgment in terms of what am I supposed to do to solve this. That's what makes this effective compared to a very typical question where students rely on pattern recognition and memory. I hope that was clear, teachers. Real life scenarios, yes.
Ratna ma'am has, I think, given an example.
Yeah.
Neither Mohan nor his friend is present today. Identify the error. Yeah. Great. Thank you all. So over to you, Aarti. I'll be stopping the presentation. You can present yours. We'll continue with principle 3. Is my presentation stopped?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay.
Aarti, you are on mute.
Sorry, I was saying I'll need your help. When I'm on full screen, I'm not able to see comments or thumbs ups, anything. So, Hetal, let me know if there's anything which I've not addressed. Am I audible?
Yeah, Aarti, so you can
Yeah.
click on 3 dots and you can go in picture. You'll be able to see that.
Picture in picture.
Yeah. Once you start presenting, go to 3 dots on Google Meet and click open picture in picture.
Okay.
Also, if there's anything, feel free. I'm right here to
Okay.
put it under the chat.
Yeah, let's go to principle 3. We have 4 more principles, and then we'll discuss a quick take home task for y'all. So this principle says that a good assessment needs to have questions covering an entire range of difficulty in a paper. So we all intuitively know that the paper should not be too tough, it should not be too easy, it should challenge students at the right level. This is one example that we've picked up from an old paper of grade 9 mathematics from ASSET. And if you can see here, you have some questions over here where the accuracy is very low. Accuracy here is 10% or like between 10 and 20. Then you have some questions which are between 20 to 30. And you have some questions which are also reaching like about 90%, right? So these are the questions which are reaching about 90%, and this shows a normal distribution of the difficulty level as per like what we also see in the classroom. Now, this is a very technical way of looking at it. Many schools do not have these kind of data analysis tools, or it's difficult for us to plot things in a graph like this and check the level of each paper. But also, if you notice the way the questions have been ordered, you have question number 30, which is the hardest question in the paper, but also question number 8 is also kind of hard. But then you have again now question 4, which is easy, and question 29, which is easy. So the sequencing also matters. You don't want to put all the questions, hard question at the beginning or at the end, and order the questions in the sequence of difficulty. It needs to be mixed so that the students are engaged while writing the paper, and overall the experience of writing the paper is balanced. Now, here's where also a lot of ambiguity comes in. So as a teacher, we may have our own perceptions. I have taught this in class, that's why this question is going to be easy. This is a very direct recall question. This is an application based questions. We have this perception that lengthier questions are harder. Questions which are maybe the questions which are which require application are harder. We all go with that mindset based on our own biases that we have. But I have done this activity with one of the schools. I would like to share a very interesting anecdote. So we finished the summer round of the ASSET recently in the month of August. And before the results started coming out, I had asked the teachers to predict. Look at the paper, just flip through the paper and identify 3 questions which you think would be the hardest for students. and 3 questions which you think would be the easiest for the students, and write down your predicted accuracy level. So if it's easy, is it going to be 80% and above? Is it going to be 60 to 70? What is the range at which you consider the question to be easy? And what are some reasons why you think that this question might be easy? So I wanted to understand the teacher's perception, and I wanted the teachers also to be more aware of the kind of ideas that they preconceived notions that they come with. And when the results came out, I did a comparative analysis. I'll show you a part of it. I don't have the whole part, but yeah. So I hope this is visible, the table. So what I discovered was the teacher's perception of what's easy and difficult really vary. So these are some questions where teachers had really underestimated the student's accuracy level. So you notice in this question, English grade 7, this question number 12, teachers had predicted that it's super hard. Only, barely even 20% of my class will be able to get this right. This was a vocabulary question, and teachers thought this is a very difficult word. But the actual accuracy was much better than what was expected. I'm sorry. Is somebody speaking?
Dhirendra sir, if you can unmute.
Yeah. Ma'am, Swarnali ma'am, if you could mute the participants. Yeah. So thank you. So you can, do you notice that there's such a big difference between what teachers predicted and what was actually achieved by the students? So I'm showing you, now this is a good thing. This is a nice thing that teachers thought that this would be difficult, but there's a big difference where 40% and where 78%. Right? And these are the reasons.
Aarti, 1 minute. I think we are able to see your picture in picture on the main presentation.
Okay, how do I quit this?
Yeah, you can just.
I tried that out. I think I'll just stop the picture in picture part and go back here.
Yes.
Yeah, thanks.
Yeah.
So these are some of the reasons which the teachers had given to tag a question as difficult. So the question is tricky. It requires knowledge of algebra. This algebra has not been taught, and my students don't know algebra. This was a grade 4-5 question where they had to create an equation based on a word problem and then solve it. And the teacher felt that algebra nahi aata, so they won't be able to do this. It requires visualization. There were some questions related to symmetry, which the teachers thought that the child won't be able to imagine this, and students have actually done much better than what the teachers had expected. And similarly, we had a lot of examples of questions which the teachers predicted would be 80 and above, but then that turned out to be at 37 or at 40%. So I would request you all, when your asset test gets over, before the results are out, you can also do the same thing. I can share a sheet with you, and you can try this out practically to understand what you think is easy and difficult may be different from what the students think easy and difficult. And with more experience and with more reflection like this, you will get a sense of what actually is easy and difficult, right? And that will help you design better question papers. So the next principle is ensuring that the difficult questions are based on good sources of difficulty. Now, going back to what I said before, we have a lot of reasons why we think a paper is, or why we think a question is difficult. So we divide sources of difficulty into valid sources and poor sources of difficulty. And what do I mean by that? So good sources of difficulty help students be challenged at the at an appropriate level. It pushes their understanding. It helps them think out of the box and develop those strategies required to answer higher order question. And poor sources of difficulty are those which can, even if the child knows the concept in your classroom, or even if they know the concept, the question is designed in such a way that it's not actually capturing whether my students know the correct answer or not. It's just tricking students up. So we will discuss this more when we do question making session in the next session. But some good sources are testing one or more sources of misconception. So a lot of times teachers feel that a question is difficult because it's testing multiple concepts. So I may have a question which is testing both adjectives and adverbs in one question, and the teacher might come and say कि ये दोनों concepts कैसे test कर रहे हैं. But in real life, that is considered a very good source of difficulty, because when we are talking, we have to remember all the rules of grammar and apply that in real life. So this is not a poor source. Similarly, we may have a question which is testing both photosynthesis and respiration, which are commonly confused concepts. So this is actually a very good thing to do. But oftentimes, since we teach chapter 1, then we move to chapter 2, we don't often take the time to connect the concepts together. We test things very chronologically and sequentially. So requiring students to identify relevant information. So like the Zeer example I gave you, the student even has to think, what do I apply? What concept do I even have to apply to solve that particular question? So that's again a valid source. Testing concepts is unfamiliar manner. That is also valid, because that's what we need to build higher order thinking. And requiring application. Bad sources of difficulty include when a question is of 1 mark, but you're giving them task which is worth 5 marks. So that is unfair, right? Similarly, when you're using double negatives in a question. So for example, which of these is a simple question will be which of these is not which of these images does not represent the correct state of matter. You're using one single negative, that is okay. But when you're using double negatives, the child has to first process that what is the question even trying to say, and it's unnecessarily complicated. I'll share a example of double negatives a little later when we do the question making exercise. And requiring using tricky or complicated questions. I've seen this a lot in English when we are doing passage-based questions. So the passage-based questions is purposely the two options are. It's not wrong to keep two options which are very close to each other, but each option should have a place in your question. So if I'm relying on the child to just use the play of words to solve the question, it is not really testing the conceptual understanding, but it's testing whether students can interpret this. Like the option is purposely ambiguous, and you're expecting the student to first correct the language of it and then answer. Then that becomes very tricky and it's unnecessarily difficult. You're not testing their concept, you're testing whether they can catch the play of words that you have done. So these are some bad sources of difficulty. I'll show you one example, and I want you all to tell me, why is this a bad question?
And if we can also have reflections around different options, and which is, say, the closest possible option, the closest possible distractor for this.
Read the entire question, not just the option, but let me know why this may not be as good a question as.
Okay, one bit is it is very lengthy.
Yes.
It is. Yeah.
What is the learning objective here?
Some words may not be clearly understood by the students. Okay, Sujata ma'am. Yeah.
Okay. Maybe one word may be indispensable if it's a young child. Indispensable may be a very complicated word to put in the question stem. Another thing is
even irking.
Irking, yes.
Irking,
irking is another hard word. So if you just want to know whether students know how to use, they know the correct form of the word didn't, do you really need to put complicated words in the question? The student might not really, like, by the time they come to the options and they actually answer the question, like they've given up already, because the question stem itself is unnecessarily complicated. It's too much reading load for the learning objective which is kept over here.
So Nanda ma'am said format. So
Okay.
yeah, I think very interesting observation. Again, Like there are too many things, and again, this child has to comprehend a lot of information here. That there are different parts to the question as well. Reading load, yes.
Yeah, reading load, exactly. So we may have, say, 30 or 40 questions in our paper. We need to make very clear decisions on where do we expect the reading, like where do we want students to read more and process the information, and where so much processing is not required, right? Those choices have to be made. Just because we want to make students think critically, like, or we want students to not answer immediately, we want them to think over the question. There's no point in making a question unnecessarily complicated just because we want them to spend more time. So the time that they're spending should also be worthwhile. It should not be a frivolous way of spending time on one question, just because we want to make the question tougher. So ensuring that the questions are based on good sources of difficulty. Now, the next principle here is using authentic data and question. We looked at unfamiliar question, and unfamiliar questions need not, unfamiliar context need not always be data-based or case-based. It could be a very simple question. But if we have to use data in our question, the idea is we should not make up data, right? Because we are purposely giving wrong information to students. So when we are putting data in our question, those should be accurate and they should be from an authentic source. It should not be made up. Because I remember when we were studying math and we were learning, area and perimeter, a lot of times the situations were so convoluted that we kept thinking, why would the cow run on the field like this, or why would somebody construct a pole that is so high, right? If you remember those examples from math, and or even with language, sometimes just to put a case based question, we want to simplify the question. Also, sometimes we find data in the newspaper and we feel that, okay, this data is too complicated to put in the paper, let me simplify it. The way we edit the original source and put that needs to be done very carefully. We should not play with the data in such a way that the question itself does not make sense. So for example, if you're keeping a question based on cricket statistics, don't put something which does not make sense at all. Use an original math statistic. So this is a question on weight. So this is again taken from a very authentic situation, which has actually happened. And now I want to show you another question. This has been taken from PISA. Just go through the details in this infographic and tell me which subject would you frame questions around. Who can frame a question around this infographic? So the infographic gives you some information about the height record for hot air balloons. It tells you some person beating the record for the highest height record of the hot air balloon, and it's giving you some information about the temperature, the oxygen levels, what was the previous record. There are a lot of numbers here. Can you think of where this kind of data you would use in your paper? How would you use this data?
Also, what we observe is like this text has written information, also a lot of visual data. So that's how learners get to interpret both of it. And also, again, this is encountering information in the real world, right? It could be a part of maybe a news article, magazine.
So can you think of any question you would want to frame around this information? You don't have to create a question right away, but can only science teachers create a question?
Is
Or
it a math thing? Is it English maybe?
what about social science? There's also temperature, geography can be asked,
Geography.
right? So uh, I'll show you what was the original question. So this has been taken from PISA, right? So the question is simply asking what is the main idea of this text, right? So the context is real. There's a lot of information given over here, and the child has to process this and answer the question. So a data-based question doesn't necessarily require students to process the data alone, but they might have to look at the entire context of how this information is being presented. So it's possible to create questions which use authentic data in any subject. It could be English, math, science, social studies. So this is a very rich source of information for creating questions, right? And if we be mindful, then data and information is all around us, and we can always use these in our question making. Going to principle 6, avoiding narrowly defining a large number of competencies and then mapping questions to individual competencies. So this is a little, I would say, controversial. Now the CBSE has given us very detailed documents with, there are a lot of detailed documents with the learning objectives mentioned, right? There are teacher energized resources. There are also the NEP has a few competencies mentioned. So, and now we have a lot of textbooks also creating a lot of textbooks which claim to be NEP aligned, and you have a few competencies listed at the beginning of the chapter. So now competencies can be very granular, right? So when designing questions, a lot of times teachers may end up being very mechanical, that I need to test students' knowledge of, for example, adverbs of frequency, that's one LO, right? Adverbs of time could be another LO. Or simply, like when I'm talking about this kind of a question, melting is one LO, condensation is another LO, evaporation is another LO. So it is possible to break the LO down to very small granular levels, and then you're not able to construct a good question around it because it's too narrow to really test something of substance. So, but when you look at this question, Kevin placed some ice cubes in a glass bottle and then closed the bottle tightly. He placed the bottle on a weighing machine or a weighing balance. And once he's placed that, there is some readings given over here. He saw water droplets forming on the inside and on the outside of the bottle, and the weight of the bottle kept increasing. So there is some situation given, and what is the increase in the weight of the bottle due to? So here the child has to apply a variety of skills, your condensation, evaporation, as well as they need to observe carefully. So observation is a very, it's something which you can't always test through a very clearly defined, LO. Your LO might say students will be able to observe so and so, but it's difficult to test unless you have a good question. So this also requires observation of the experimental setup. It requires students to know how experiments are designed. Now, these things might be left out in a typical, chapter. Experimental skills may not be covered in any chapter per se. So a good question is not, when you're designing a question, the overall, we should not do this in a very mechanical manner, that ye LO meet karna hai, so I will put these. Sometimes you may lose out on a very good question just because it's not fitting the pre-planned LO which you had in mind. So designing the items is more important, and then mapping the LO can happen along with that. There should be a balance between both, but don't lose on a good question just because you're not able to fit that into what you had previously decided. That's the idea behind this. Don't make question making a very mechanical process. Now we come to the last, principle: using different question types to test different aspects of student competencies. So with ASSET and generally, we focus a lot on MCQs. And you may have seen a lot of examples of MCQ questions from what the kind of work EI does. But we do believe that MCQs cannot achieve all the objectives of an assessment. Sometimes you need other question types. So like all of you are familiar that we have diagnostic assessments, we have formative assessments and summative assessments. And there are a variety of tests which can be given in each of these types of assessments. So you can give students a survey, you can give them a thinking task, a KWL chart, what I know, what I want to learn, and what I've already learned, right? So similarly, when you're doing a formative assessment, it's not necessary that everything needs to be in the form of an MCQ. It can be quick graphic organizer that can be given as an assessment itself. Similarly, you can give diagrams as an assessment. So if I know what water cycle looks like during the day, can I visualize what water cycle looks like at night, right? Extending what they've already learned and making them represent that in a variety of ways. Similarly, your summative assessment also does not need to be only a test with subjective marks. It could be a book report, it could be a research. Schools are now also including portfolio. So, but the task needs to meet the purpose of what you're trying to achieve, right? I want to show you a few examples of how to apply this principle. So I've taken this from one of the math textbook. A lot of math textbooks have these kind of properties when you're teaching factors and multiple, right? The smallest factor of every number is 1, and every number is a multiple of 1 in itself. So when these things are tested, a lot of textbooks may have some true or false or fill in the blank based question. Now that might help students remember some of these properties, but uh, you know but then it may not achieve all the purposes of it may not really help you understand whether students have understood these properties. So I'm going to show you 2-3 tasks which can be given to check real understanding in these questions. And again, your typical textbook will include questions like this. Find any 5 factors of the following numbers, right? Find the prime factors of the following numbers using the factor tree method. So if I have to go and really test whether students have understood these principles, can somebody look at question 1? Which of these is both 3 and 8 as factors? The data also has been presented. Can you tell me what misconception do students have?
Anybody, please feel free to use the chat box as well.
If the question is giving you that which of these is both 3 and 8 as factors, and some students have selected option 1, which is 1, what misconception could this reveal about students' knowledge of factors?
And again, it's a major chunk, right? 31% of the children thinking. So there's a clear learning gap and a misconception around it.
Yeah.
Anybody? Groupings is what Sangeeta ma'am said.
Okay. Why would the child think option 1 is right?
One is a factor of every number.
Yes,
Thank
yes,
you. Thank
exactly.
you, ma'am. Yeah.
Yeah, thank you, ma'am. So students know that rule, but and another thing is when you go back to textbooks, you see that normally what is unknown in the question is the factor, right? So this is a standard way of asking. Find any 5 factors of the number. The number is known, but the factors are unknown, and you list the factors, right? But in this case, the question is designed slightly differently. The number is unknown, but the factors are known. So when the format is unfamiliar, their students are now mechanically trying to remember the rules, and students might think ye do number hai. 3 and 8 are the numbers, and I have to find the common factor. And since 1 is the common factor of both these numbers, students have mechanically selected 1. So now this is a good example of an MCQ which is actually getting that misconception out. And once you know that this is a misconception, I can use some formative tasks, or I can give students some interesting tasks to understand or like direct them to correct thinking. So now students have also learned the definition. A natural number can be a factor of another if it divides the given number exactly, and the remainder is 0. So now this question is showing them an example of what exact division looks like. So 8 being divided by 4, you are forming 2 groups and the remainder is 0. But then 8 is not divisible by 3, right? So now the question says the visual above shows 8 is exactly divisible by 2, but not by 3. That is why 2 is a factor of 8. Now I have given the child information. Can I tell them to then, students have also learned that factors of a number are always smaller or equal to that number, and a number has only limited set of factors, right? So if I know that my number is 8 and only 2, I know one factor is 2, can I figure out, can I draw and show how many numbers divide 8 exactly? And then I can extend this task and tell students to again figure out how many numbers can 8 be a factor of, right? So students can they connect factors and multiples and realize that each number can be a factor, sometimes can be a multiple sometimes. So now these are some thinking and reflection tasks. This is a straightforward MCQ, and this is a task which asks students to visualize their answer, to show the answer. So this can be easily a homework activity. It can also be asked in a summative assessment. So our summative questions need not always be calculate something and show the steps. It can also be something like this. So this is a summary. We are at the end of our session. I will be sharing this PPT with you all so that you can recap some of the principles. Few key ideas are that we need to test core concepts or key concepts and not peripheral facts. Use unfamiliar questions, and also keep in mind the kind of misconceptions students are likely to have and include those deliberately in your questions. Before we end this session, I wanted to share one task or one homework with you all. You can take a screenshot of this, and again, you'll see this in the PPT. Now, how will you apply what we have learned? You can open any chapter from your textbook, make a list of, try to just flip through the page and identify what are some of the core concepts which need to be tested, what's a need to have, and what is a nice to have, right? And go through the textbook exercises and the question and answer and check, is the question and answer part covering all the essential concepts? If not, what do I think is important to cover, which has not been covered in the Q&A? And what are some unfamiliar ways in which these key concepts can be tested? So like I showed you, this question is familiar, right? But this question is unfamiliar. But the textbook does not have something like this. So what are some gaps in the textbook, and what do I need to deliberately incorporate so that that conceptual understanding is built? And then try and create 2 to 3 questions testing the same concept in different ways. Maybe one can include data, one can be a very short, simple MCQ question, one can be a reflection task, right? And you can document the rationale behind your choices and do a department level discussion on why you think these questions are meeting the purpose of your assessment. Right, we are right at 6 o'clock. I would like all of you to, I would like to thank you all for your patience and for your participation. I hope this session was useful to you all. And if you all could take a picture of the QR code and, fill up the feedback form, this will help us tailor the future sessions better. This was a very short, crisp, 1 hour session, and we've discussed a lot of big ideas for you.
Requesting everybody to scan it or take a screenshot, and then you can give us the feedback.
Aarti, post session, if you will share the QR code or the form link, it would be very helpful.
Sure,
Yeah,
Aarti,
sure,
we'll do that.
ma'am. Yeah.
Great. Thank you all for your time. Thank you for being a very engaging audience.
Thank you so much.
Yeah,
Hetalji, thank you so much. Aarti has been with us on CC Friday earlier also for a session. So thank you so much, Aarti, once again conducting the session. I hope the team has got a lot of insights, and we will be able to see already they are doing a very good work and framing good questions, but definitely it will help them to even do better.
Definitely, definitely. Thank you.
Thank you so
Thank
much.
you so much. Yeah.
Thank
Bye-bye.
you.
Thank you.
Wishing you all a happy Diwali as well.
Happy Diwali.
Thank you.